There are few sounds more pleasing to an aviation specialist than the quiet hum of a well-maintained aircraft. The subtle noise indicates that propellers and rotors are balanced, plus vibration and noise are minimized, so flight is smooth and peaceful. But the benefits of balancing go beyond what is seen, heard, or felt. A properly balanced propeller or rotor reduces instrument, avionics, and engine wear, helps to prevent catastrophic engine failure, and prolongs aircraft life. Balancing helps ensure that flights are not only smooth, but also safe. Everyone knows that proper balancing and good maintenance takes the right tools, and that's something we take pride in at ACES Systems, creating better aviation maintenance solutions. All products in the ACES Systems family share the common traits of ease of use and versatility. Our products measure engine vibration, noise levels, monitor and trend engine performance, as well as perform dynamic propeller balancing and rotor track and balancing. The ACES Systems Model 2020 ProBalancer Analyzer is a visionary tool for performing propeller balancing and rotor track and balancing. This tool is easy to use. On-screen instructions step you quickly and easily through balance jobs, so you need little to no training in propeller or rotor balancing. Beyond simple balancing, the Model 2020 offers the advanced feature of full spectral analysis, allowing you to view a wide range of minute frequencies for all rotating components. The Model 2020 also accepts data from 2 channels simultaneously, allowing you to compare vibration frequencies from 2 propellers or rotors, facilitating and increasing the accuracy of balancing. The remainder of this video will step through the operation of the Model 2020 ProBalancer Analyzer. Part 1 will concentrate on balancing. Part 2 will be an overview of how to use the instrument for spectral analysis. This video presents only the basic steps needed to get you up and running. The video cannot replace the detailed information found in your user's manual. Refer to it frequently to help you through the process of performing propeller or rotor balancing. Before beginning, it's important to familiarize yourself with your new equipment. The Model 2020 ProBalancer Analyzer comes with basic accessories. The Model 2020, a battery charger, a communications cable for connection to a printer or computer, and a user's manual. The Model 2020 Helicopter Balancing Kit includes everything you need to do the job: the optical tracker and the interface, 2 vibration sensors and 2 vibration cables, a magnetic pickup and pickup cable, a PhotoTAC and PhotoTAC cable. Also included are applicable brackets for the airframe and this training video. Now you're ready to begin. To begin, use the installation location specified by the aircraft maintenance manuals or balance charts. Note that the Model 2020 only recognizes single interrupter logic. Install the magnetic pickup as directed in the maintenance manual or applicable balance chart. Connect the magnetic pickup cable to the magnetic pickup. Secure to the airframe, taking care to route the cable away from flight controls. Install the lateral vibration sensor as directed in the maintenance manual or applicable balance chart. Connect the vibration cable to the sensor and secure to the airframe, taking care to route the cable away from the flight controls. Install the vertical vibration sensor as specified by the maintenance manual or applicable balance chart. Connect the vibration cable to the sensor and position away from flight controls. To begin the main rotor track and balance, first turn the analyzer on. Use the up and down arrows to navigate the screen until the selection Main Rotor Track and Balance is highlighted. Press Enter. The screen will display the Main Rotor Track and Balance banner across the top. Select Start a Job by using the up and down arrows and then press Enter. The main rotor setup screen appears. Default values in some fields appear automatically, but can be changed to more appropriate data. Enter the name of the aircraft by using the analyzer keypad. Let's say your aircraft is an AS350. The letter A is the second option on the key. Press the key 2 times rapidly, and the letter A appears on the screen. wait 2 seconds, and enter the next letter. In this case, the letter S is also the second option on the key. Press the key 2 times rapidly and wait 2 seconds. Proceed until the correct name appears on the screen. If you make a mistake, use the right and left arrow keys to position the cursor to the right of your mistake. Press the clear key and select the correct letter. Use the down arrow to progress to the next field, vertical channel. Note that this entry box has pointed ends. The information for the pointed end boxes cannot be entered from the alphanumeric keys. Instead, use the right and left arrows to navigate to the most appropriate selection. This selection determines which channel the analyzer uses to measure and display the vertical vibration. Repeat this procedure for the next field to determine which channel is used for lateral vibration. Sensor type is selected from a list of applicable sensors. The 991D1 is the standard sensor provided with the Model 2020. Use the right and left arrows to navigate among them and choose the correct sensor. Tack type gives you 5 options to choose. Use the right and left arrows to pick the appropriate option. For main rotors, mag high is most common. Tack channel corresponds to the tack input port from the once per rev source used for balance. Navigate using the left and right arrow keys to select the appropriate channel. For blades, use the right and left arrows to navigate and select the number appropriate for the main rotor system. The relative to selection determines the manner in which tracking data is displayed. The selection of average displays the blade track data according to the mean or average position of all blades. The selection of an assigned blade number displays all other blade positions relative to the selected blade. For blade RPM, use the keypad and enter the maximum expected RPM of the rotor system. Toggle for track units and enter either inches or millimeters as your unit of measure. The last field allows you to define 6 flight conditions under which you may acquire and store run data. Use the keypad and enter flight conditions up to 6 characters each. After all fields are completed, press the Enter key. A screen appears asking if you'd like to store this new setup. Press F1 to accept and store the setup. The customer information screen appears. Entering this information is optional, but providing a customer name is recommended, as it will aid in identification of the job for resuming or reviewing purposes at a later date. Press Enter when finished, or to bypass this screen. The tracker selection screen appears. Choose the type of tracking device used with this job. If using an industry standard strobe light, select Strobe and press Enter. If using the ACES System Model 540 optical tracker, select Tracker. If using the Model 540 tracker, press the down arrow to move to the number of rotations field. Otherwise, press Enter to continue. Use the keypad to enter the desired number of rotations for acquiring track data. Press the down arrow and progress to the inches to blade tips field. Use the keypad to enter the distance between the tracker's operating location in the cabin and the blade tips. After all fields are completed, press the Enter key to continue. The main rotor equipment setup screen appears. This screen directs you to install and connect the tack and vibration sensors you specified in the setup. Attach the pickup cable to the tack channel specified in the setup. Connect the lateral vibration cable to the channel specified in the setup. Connect the vertical vibration cable to the channel specified in the setup. Connect the Model 540 tracker cable to the interface. Connect tracker interface to analyzer's aux-com port. With connections complete, press Enter to continue. The Start Aircraft screen appears. Start the engine according to flight manual procedures. Press Enter to continue. The Select Aircraft Condition screen appears. This screen is used to keep track of the measurements from various flight conditions defined during setup and to exit the current run when finished acquiring data. Use the up and down arrows on the keypad to select a condition and press Enter. An X preceding the condition name indicates that measurements were taken and stored. The analyzer now displays vibration data. The current and average RPM frequency, IPS, and clock angle are displayed along with a percentage error and averaging indicator. When the percentage error reaches its lowest point, press the Enter key on the analyzer. The Review Data screen appears. To retake the data just collected, press the F1 key. To take track data, press the F3 key. To continue to the next step, press Enter. The Select Condition screen reappears. Select another condition to measure or press F1 to end the current run. If you selected to end the run, an information screen appears advising you to shut down the aircraft in accordance with the flight manual. Shut down the aircraft and press Enter to continue. The Review Prior Runs screen appears. The run number is shown, followed by the condition. Use the up and down arrows to view the various conditions measured within the run. Take this information and plot it on your charts to determine the corrections needed in accordance with the applicable maintenance manual. When corrections are complete, press the F3 key to continue with the next run, or press the F1 key to quit and store the job data. Press the Main Menu key on your analyzer, then select and enter the Miscellaneous Items subheading. Under Miscellaneous Items, select and enter Printer Setup. For detailed instructions on how to set up your specific printer, refer to the section in the Model 2020 User's Manual titled Printer Setup. After setting up the printer, press the Main Menu key. Connect the communications cable to the analyzer and the printer. Make sure the power is on for the printer. Select and enter the subheading that contains the information you'd like to print. From this screen, select and enter Manage Jobs. From this screen, select and enter the Print function. Select a job to print and press Enter. The analyzer screen indicates the status and when the printing is completed. Install the vibration sensor and applicable bracket for your installation in accordance with the maintenance manual or applicable balance chart. Attach the vibration cable to the sensor and wrap forward around tail boom toward the cabin. Rotate the tail rotor assembly to the vertical position. Install the PhotoTack and applicable bracket to the tail rotor gearbox and align the tack toward the tail rotor blade to be used as the target blade. Attach the tachometer cable to the PhotoTack and wrap forward around tail boom toward the cabin. To begin the tail rotor balance, first turn the analyzer on. Use the up and down arrows to navigate the screen until the selection Tail Rotor Balance is highlighted. Press Enter. The screen will display the Tail Rotor Balance banner across the top. Select Start a Job by using the up and down arrows and then press Enter. The Tail Rotor Setup screen appears. Default values in some fields appear automatically, but can be changed to more appropriate data. Enter the name of the aircraft by using the analyzer keypad. Use the down arrow to progress to the next field, Sensor Channel. Note that this entry box has pointed ends. The information for the pointed end boxes cannot be entered from the alphanumeric keys. Instead, use the right and left arrows to navigate and choose the appropriate selection for which channel the analyzer will use to measure and display tail rotor vibration. Sensor type is selected from the list of applicable sensors. Use the right and left arrows to navigate and choose the correct sensor. Tack channel corresponds to the tack input port from the once per rev source used for balance. Tack type gives you 5 options to choose from. Use the right and left arrows to pick the appropriate option. For tail rotors, optical is the most common. For tack position, enter the clock position of the PhotoTack as viewed from where you would stand as if using a strobe light to acquire clock angle. For balancing RPM, use the keypad to input the tail rotor RPM expected when balancing. Rotor direction is the tail rotor direction of the rotation as viewed from your position as if using a strobe light to acquire clock angle. Toggle and choose between clockwise and counterclockwise. For blades, use the right and left arrows to navigate and select the number appropriate for the tail rotor system. After all fields are completed, press the Enter key. A screen appears asking if you'd like to store this new setup. Press F1 to accept and store the setup. The customer information screen appears. Entering this information is optional, but providing a customer name is recommended, as it will aid in identification of the job for resuming or reviewing purposes at a later date. When completed, press Enter. The tail rotor equipment setup screen appears. This screen directs you to install and connect the tach and vibration sensors you specified in the setup. Attach the tachometer cable to the channel specified in your setup. Attach the vibration cable to the channel specified in your setup. Examine the bottom of the tail rotor equipment setup screen. You will see the Tach On option. Press the F1 key to activate this option. Thoroughly clean the area on the target blade where you intend to place the reflective tape. With the tape backing still in place, hold about a 3-inch strip of reflective tape in position on the target blade in front of the phototach. Move the rotor assembly back and forth to ensure the red LED gate indicator light on the back end of the tach turns on and off as the tape crosses the beam. Then, flap the rotor assembly to verify beam contact through full tail rotor motion. Note the position of the tape on the target blade. Remove the backing and apply the tape firmly and smoothly to that location. With the equipment setup complete, return to the analyzer and press Enter. The Start Aircraft screen appears. Start the engine in accordance with the airframe flight manual and set the tail rotor RPM as specified in the tail rotor job setup. When RPM is set to the desired level and stable, press Enter. The analyzer now displays vibration data. The current and averaged RPM frequency, IPS, and clock angle are displayed along with a percentage error in averaging indicator. When the percentage error reaches its lowest point, press the Enter key. An information screen appears advising you to shut down the aircraft in accordance with the aircraft flight manual. Shut down the aircraft and press Enter to continue. The Review Prior Run screen appears. Take the current run data and plot it on the applicable balance chart for corrections. When corrections are complete, you can proceed with the next run by pressing Enter or F3. To end the current run, press F1. To print a report, follow the same procedure used for the main rotor. Using spectral analysis allows you to complete and store surveys using the setup feature. Several different components can be surveyed without manually entering the setup data between surveys. To begin, press Main Menu on your analyzer. Select and enter Vibration Spectrum Surveys. From this screen, select Start a Job.